So today's test is called the t-test, or the mean. And the t-test for the mean is very similar to the z-test for the mean, except this time we don't have sigma. So sigma is unknown. And there's a couple of assumptions. The population that we're looking at should be normal or approximately normal. But what's going to happen is, obviously, every day we meet, and I'm doing a new hypothesis test, I have to give you two things, right? What distribution does it utilize, and what is the TV formula, okay? So today's distribution is obviously the t distribution. And then when we look at the t distribution for this particular test, the degrees of freedom is n minus 1. We saw that before when we did the confidence interval for the t distribution. And then the second thing I need to tell you is what is the test value formula for this particular test, okay? So it's going to be t equals x bar minus mu naught divided by, again, we don't have sigma, so we have s divided by square root of n. So we're using the t distribution, and we have this as our test value, but pretty much all the steps that we did before are going to be pretty much the same, okay? So one thing that we want to practice a little bit is just getting the correct critical value or critical values, okay? So let's do a couple of examples where we're just establishing, making sure we remember how to do critical values using t distribution. All right, let's say we have a right tail test. So let's do example 1. Let's say we've set it up. We have a right tail test. We have alphas at 0.05, and we have n is 23, and I just want your critical value. Okay? So let's make sure we understand this. It's a right tail test, so that tells me we have area in the right tail. In fact, alpha is 0.05, so that area is 0.05. And I want to know what this critical value is here. It's a t distribution, so it's going to be a t value. Okay? Well, I have to open up my chart, my t distribution table. And I need to be able to figure out how I can get this t value looking at from off of my charts. Okay, so across the top you have confidence interval, which we used last time, but then right underneath that we have one tail alpha. Okay, so that's going to be obviously where we go, because this is a one tail or right tail test. So we're going to go to one tail alpha at 0.05, and then we're going to go down to, if n is 23, we're going to look for 22 degrees of freedom, and hopefully it's in there. If it's not, we'll go to the closest smaller value. So notice we have 22 degrees of freedom, we have one tail 0.05, and the value is 1.717, okay? Now, because this was a right tail test, it's positive 1.717. However, if this was a left tail test, then what would change about this 1.717? It would be negative, exactly, okay? So that would be my critical value, which would be step 2 when we're doing a traditional hypothesis test. Okay, let's try another one. Let's say we have two-tailed test. Alpha is 0.05, degrees of freedom is 17. So example 2, we have a two-tailed test. Alpha is 0.05, and df is 17. And I want to know what the critical values are. Two-tailed test. Alpha is 0.05, degrees of freedom is 17. Okay, so if I know it's a two-tailed test, I need to split that total alpha area in two parts. So if this is 0.05, this has to be 0.025. And this area here has to be 0.025. We have two critical values on the negative side and on the positive side, and the degrees of freedom are 17. Okay? So look at your chart. Notice the third row says two-tailed alpha. So So we're going to go to a two-tailed alpha. Alpha is 0.05, so you're going to go to the column with two-tailed alpha, 0.05, and then we're going to go down to 17 degrees of freedom. And if you read off that value, it says 2.110. So we're going to have 2.110 on the positive side and negative 2.110. That will be my correct critical value setup. Okay? And if you notice, guys, with the one-tailed and two-tailed, it's set up. If two-tailed is 0.05, then that's the same column as one-tailed at 0.025. Okay? So you can't go wrong either way. If you looked at just one-tailed, it would still be the same column. Okay? So obviously you have to get this right to be able to go on, because it's dependent on where your test value lies, and then you might reject or not reject wrongly if you don't have the correct critical value. All right, let's do a full test now. Okay, here we go. The manager of a car rental agency claims the average mileage of cars rented is less than 8,000. Okay? A sample of 5 cars has an average of 7723 with a standard deviation of 500. At alpha equals 0.01, is there enough evidence to reject the manager's claim? Assume that this is normal. Okay, so let's look at the first sentence. The manager of a car rental agency claims the average mileage of cars rented is less than 8,000. Okay, so the main thing of importance there, claims average mileage is less than 8,000. Okay? So the claim is the average mileage is less than 8,000. A sample of 5 had an average of 7723 with standard deviation of 500. Okay, so we have this sample. We had 5, so n equals 5. We had the sample mean is 7723. And then right next to that it says with a standard deviation of 500. Okay? So that standard deviation is always assumed to come from the sample. The only way we go otherwise is if it explicitly states the population of the standard deviation is this. Okay? And it's not going to do that for any of these t-test problems. It's just going to say, here's your sample, here's your mean, here's your standard deviation. And that's always going to be assumed to be S. Okay? So that was 500. Okay, great. Then it says that alpha equals 0.01. Is there enough evidence to reject the manager's claim? So we want to answer this question. At alpha equals 0.01, can we reject manager's claim? So in our summary write-up, let's answer that. Can we reject manager's claim? Okay. So let's go through the 5 steps. Do you have a question?
Yeah, can you read the part after 8,000? A sample of 5, and then...
A sample of 5 cars had an average of 7723 with a standard deviation of 500. So n was 5, x bar 7723, and s was 500. Okay? All right, we're going to do a traditional hypothesis test. There's 5 steps. Step number 1, we need to state the null and alternative hypothesis. Blah, blah, blah claims the average mileage is less than 8,000. Where's that going to go? Mu is less than 8,000, and that is the claim. It has to go there because less than does not have an equal sign, and an equal sign always goes in the null. Okay, and again, I like to use greater than or equal to, even though your book uses equal to, but I think this way is easier to understand. Okay, step 2. Based on step 1, what type of test do I have? Right-tailed, left-tailed, or two-tailed? Left-tailed, okay? So I draw my critical region. I have a left-tailed test. So my critical value is on the left side. Alpha is at 0.01. So this area here is 0.01. Okay? N is 5, so my degrees of freedom is 4. So I need to go to my table. I need to look at 0.01. N is degrees of freedom is 4. So let's do that. One-tailed test. Alpha is 0.01. Degrees of freedom is 4. You get 3.747 on your table. This is on the left side, so it's negative 3.747. And that's the end of step 2. finding your critical value in your critical region. Okay? So again, I just looked at one-tailed, alpha's 0.01, and if n is 5, the degrees of freedom is 4, and that's where this value comes from. In the table, it just gives positive values, but we know it's on the left side, so it's a negative value for the t-distribution. Okay? Okay, let's move to step 3. I'll just put it over here. That's your test value formula. So you guys have the formula. It's in your notes. Plug in the values. T equals x bar 7723 minus the hypothesized 8,000 divided by 500 divided by square root of 5. Be super careful how you plug this into your calculator. So many places you can mess up, so just be really careful with the complex fraction. Okay? So let's plug this in and see what we get here. Okay, I'm getting approximately negative 1.2388. Negative 1.2388. So t is approximately negative 1.2388. If I go to 4 decimal places, which I tend to do. Okay? And that is the end of step 3, which is my test value. Then I just drop this test value on my original graph. Okay? I see my CVs at negative 3 something. My test value is here at negative 1.2 something. Clearly, it is not in the shaded or rejection region, so that leads me right to step 4, which is do not reject HO. At the end of step 4, 2 things happen. Either I reject HO or I do not reject HO. Okay? In this case, we are not rejecting this, so we're keeping that. I'm going to circle that, but we're going against this. Okay? So circle what we're keeping, and then cross out what we're not. Then step 5, in my own words, what happened in this problem? Can we reject the manager's claim? Yes. Okay? We don't believe the manager's claim, or there's not enough evidence to suggest the manager's claim that the average mileage is less than 8,000. Okay? So however you want to put that in your own words. Not enough evidence to agree with manager. Or to support manager's claim. Okay, very similar to a z-test, but now we're using a t-distribution. The difference is we have s instead of sigma. Okay, and you use the t-distribution instead of the z-distribution. Any questions on that problem? So we did a left-tailed test. Let's also do a two-tailed test, for example. So let's try a two-tailed test. All right. A city claims the average cost of a car wash is $8. All right, example 2. City claims the average cost of a car wash. Average, again, you're going to see average or mean in all of these. Cost of car wash is an important word. It's not greater than or less than or at most or at least, just is $8. Okay? A sample of 10 car washes had an average price of $8.70. So a sample of 10 and a mean of $8.70. With a standard deviation of 30 cents. All right. Test claim at alpha equals 0.05. Okay, so if you have this problem on your next exam, how do you know that this is a z-test versus a t-test? What is the clue that tells you this is a t-test versus a z-test? Sample of 10 had a mean of 870 with a standard deviation. Okay, where is that coming from? That's coming from the sample. Okay, when I see that that's coming from the sample, I know it's a t-test. Because in a z-test, it has to say the population standard deviation is blah, blah, blah. Okay? Otherwise, the tests look identical. So it's really important that we concentrate on, oh, okay, that's a t-test. Because otherwise, you're going to use the wrong test, and it's hard to get points when you use the wrong test. All right, so what is HO, H1 in this problem? What is the claim? The average cost of a car wash is $8. Mu equals $8. Where do I put that? In HO, right? Mu equals $8. All right, the alternative is mu is not equal to $8. And if you want, this is the city's claim right here. Okay, at the end of step 1, I know I have a two-tailed test because it's an equals not equals. So when I go to my t distribution, I'm going to have a critical value on the right side and the left side. And the total area that I've shaded in here adds up to alpha. Alpha is 0.05. So this area here is 0.025, and this area here is 0.025. Okay? We looked at 10 cars, so my degrees of freedom is 9. All right, so you go to your t-distribution table. You go to alpha is 0.05. You go to 2 tails. Go down to 9 degrees of freedom and read off that number. Okay? So it's 0.05, it's 2-tailed. Degrees of freedom is 9. So 2.262. Did everybody get 2.262? 2.262 on the positive side and negative 2.262. Okay, and again, that's alpha is 0.025 in 1 tail or 0.05 in 2 tails, and degrees of freedom, is 9, 2.262. Please make sure you can see these numbers, because otherwise you're not getting the step 2 correct. Okay, and it's super important. Each step leads to the next, right? This tells me it's 2-tailed. Right? This tells me where to label my CVs. Next is my TV. Okay, go ahead. Do the TV yourself and tell me what you get. And I'll do it while you're doing it. So 870 minus 8, all divided by 30 cents, all divided by the square root of 10. Be super careful with parentheses. You will need them. Whoa. I'm getting about 7 something. 7.3786. Okay, so at the end of your test value, you should get about 7.3786. Where is that on this picture? It's way out here somewhere, right? 7 point whatever. So clearly, it's well inside my rejection region. If my test value falls in my rejection region, step 4, I reject HO. Okay, so I come up here and I'm rejecting HO, putting a big cross through that, and I'm going with H1. Mu is not $8. In my own words, what happened? The city claims the average cost of a car wash is $8. Based on our findings, we don't agree with that. There you go, and you're done. Okay? So city wrong. Any questions on the t-test for the mean? Each day we're adding more and more tests. So it's so important that you can do these first couple because they just get more and more complicated. Okay? Question?
So do you always put in the HO, H1, do you always put the equal on top and the not equal on bottom?
Yeah, so there's always an equal sign here. It's either equals, greater than or equals or less than or equals. That's the only thing that can go here.
Okay.
Everything else goes here. Okay. Other questions? All right.